guys, this is Patrick from STH, and this is my Netrio Nugget 2023 presentation. Now, if you're just joining us, I've been doing these presentations for this Nugget conference since I think 2020 or so. And what I like to do is really focus on what are the next generations of technologies that you need to know about in the next, 1 to 3 years. And if you were to go back into my previous presentations, you would probably see that, well, a lot of the stuff that we talked about is actually coming to fruition these days. Now, if you don't know STH, we're the largest server storage and networking review site. We started doing YouTube in about 2020, and then just recently we hit 300,000 subscribers on our YouTube channel, and as I'm recording this a couple days later, we're now at 320,000 subscribers. And we cover all kinds of really cool stuff, but we do focus a lot on the data center, and that's where we're gonna focus a lot of our attention on today. And I know we have a number of regular STH viewers out there that are probably wondering what the heck this set is. If you didn't hear it, we are moving to Scottsdale, Arizona, so this is a totally temporary battery-powered setup, but we do have a giant new 2,400 square foot studio that we're putting in that we should start using in early November 2023. So stay tuned for that. But in this talk, I want to talk about a couple of the big topics in the data center. The first one, of course, we're going to talk about AI because that is a huge power in the data center. It's driving IT spending like crazy, and I'm going to talk about why. And then I want to talk about traditional CPU compute, because I think with the AI train, the CPU side has gotten totally just kind of left behind, and at the same time, it's probably one of the more exciting areas. The other two things that we're going to talk about is, number one, networking, because I always talk about networking and interconnects, and it's super interesting and exciting. The other thing I want to talk about, and I'm going to sprinkle in all of these discussions, is liquid cooling, because that has been another theme over the last couple of years, and folks are going, I guess, gaga over liquid cooling and all different types of liquid cooling. So we're going to talk about what that means and also what it means for your data centers and how you can plan your deployments. With that, let's get to everybody's favorite topic these days, and that's AI. Whether you're excited about ChatGPT or maybe you owned NVIDIA stock and you've seen that thing go crazy over the last year, generative AI has been a giant force in the industry. It started to pit newcomers like OpenAI against and also along with companies like Microsoft, Google, and others. Now, I'm guessing most of the folks that are watching this have probably used generative AI, whether that's generating text or maybe coming up with images or maybe editing some video or something like that. Generative AI has become a giant force in the industry. And one of the things that has really led to being able to do generative AI is NVIDIA's GPUs and also being able to scale those GPUs to solve large scale problems. It turns out that the vast majority of what we see today as generative AI, really those models could not be trained when you only had, 128 GPUs or something like that, smaller clusters of GPUs. Instead, you need to scale out to many thousands or tens of thousands. And now folks are looking at how do you scale to hundreds of thousands of AI accelerators. So when we talk about AI, there's really two things. There's training, and that's what uses a ton of compute resources and very expensive resources. I mean, we're talking about AI accelerators and GPUs that can be 10, 20,000 or more dollars a piece. For example, when we do reviews of these like 8-way GPU servers from NVIDIA, those things nowadays cost about $250,000 each. And that's just for the server. The other side to it is you need high-speed interconnects, whether that's InfiniBand, Ethernet, or both in a network. And once you have the GPUs and you have the high-speed networking, you also need things like storage also connected to a high-speed fabric, and then you just need to power and cool these things. Each one of the modern NVIDIA 8-way H100 servers, they all use somewhere in the 8 to 10 kilowatts per server range. And so that means that if you have a standard North American rack that's 208 volts, 30 amps, something like that, you can't even run one of these servers in a rack. And so what you see when you go down data centers these days, you see these like AI clusters, and you'll see that they're maybe have one server in them. There may be like one server every 2 racks. Sometimes you see like 2 servers in a rack, but you don't necessarily see them full anymore. And so that's just something that's a little different these days. And while we talk about training and everybody gets very excited by training, just remember that training these large generative AI models, like something like a ChatGPT, like a next gen, like ChatGPT 5 or something like that, you're not talking about something that's $1 million to train, or just maybe $10 million if you're using cloud instances to go train it. You're not even talking about like that category. You're talking about hundreds of millions of dollars and possibly over $1 billion just to go buy all the compute resources or to use the compute resources in a cloud to train a large scale model over the course of what's likely likely a month to maybe a couple months. So the bottom line is that most organizations frankly can't afford to go and train one of these large scale models because it's just too darn expensive. And so something that we're starting to see more of is enterprises are taking these large models and they're taking their own data to go create what are essentially little expert networks. And these expert networks are much smaller and they're much easier because you're starting with a pre-trained model and then you're just kind of training it and tuning it on your own data. And that can be done a lot more inexpensively. So that's kind of what we're seeing a lot more organizations do these days. But that task alone is creating a giant demand for GPUs. And listening online, you might think that the demand is all about the training side, but realistically, the bigger cost in a lot of these is actually on the inferencing side. It's every time you go into ChatGPT and you say, hey, write me something, that is actually extremely computationally expensive. And because it's both expensive, but also easier to scale and to use different types of hardware, we're seeing a ton of different organizations use not just AI accelerators that were typically used or targeted at training, but there are other companies like, for example, AMD and other folks are coming in and saying, hey, we can go do this inference side. And that's really where most of the money is. So if you're sitting there and your boss is telling you like, hey, we need to go train our own ChatGPT, you don't need to go do that. What you probably want to go do is take a base model and then tune it using your data. And that's a much smaller task. But then the bigger thing you should be talking about and thinking about is really the AI inference side. And just to kind of give you some idea of like how awesome these chips are, here's a picture of me recently in San Jose, California, and that is an NVIDIA A100, which is the previous gen high-end GPU. Then there's the new L40S, which is the inferencing GPU. And then there's the H100. And I was told that this little stack is worth about $50,000. And these are not even really the high ones. These only use somewhere between 300 and 400 watts per GPU. But if you're to go do high-end training in one of those systems, you'd probably have a GPU that's using 700 watts and potentially even more. And 700 watts per and having 5 in a system seems like a lot. But next generation, we're gonna start to see that creep up to 1 kilowatt per GPU. So 8 GPUs, 1 kilowatt each. That gives us 8 kilowatts just for the GPUs, plus another probably 2 or more kilowatts for some of the other stuff that's in the server, like the storage, networking, the CPUs. And then you have to power and cool that. So from the AI hardware standpoint, there are a ton of really cool companies like Cerebras, which they're doing the wafer scale engine, like these giant, literally taking the largest square you can make out of a wafer that comes off of TSMC, and they're making an AI accelerator just based on that. And there are a ton of other companies that are coming out with kind of cool architectures to go do, especially the inferencing side, but also some of the training side. And just for some sense, every hardware vendor I'm talking to is saying like, hey, we have so many $100 million GPU deals that are out there that we literally can't even get enough GPUs for at least 6 months to be able to fulfill that demand. That's how crazy the AI side is, and that's why you hear so much buzz about it. And also there are a lot of really cool use cases too, so I think that gets people really excited. Okay, so let's talk about the next part, and I want to talk about CPUs for a moment. So on the CPU side, if you didn't know this, the Intel Xeon CPUs have been just kind of like the standard in data center for generations. Now, companies like AMD have made inroads, certainly with x86, but there are ARM vendors that have made inroads, such as AWS with its ARM-based Graviton processors, and also companies like Ampere Computing, which have these, which is an Ampere Ultra Max, which is the 128 core part. They have a new Ampere 1, which is 192 cores, and that is a lot of low power cores. But the x86 side, let's be clear, is not staying still. And just to give you some sense of how crazy this is, in 2017, the highest core count, brand new Intel Xeon, the Skylake generation, Platinum 8180, those things cost like over $10,000 in 2017, pre all this inflation dollars, right? I mean, these things were super expensive, and you could get 28 cores per CPU. If you went ahead and you fast forward to 2021 and the beginning of Q2, the highest core count CPU you could get is the Platinum 8280, which was also 28 cores. But over the last couple quarters, core counts like 28 cores per CPU or 16 cores per CPU are completely irrelevant in the data center at this point. We now have things like the current Sapphire Rapids Xeons, which normally top out at about 56 cores, but there are 60 core variants. We're gonna have a 64 core Emerald Rapids processor line that will, I think, launch on December 14th, 2023. And the other thing you can do today is you could get AMD EPYC Genoa and Genoa X processors. The Genoa processor will go up to 96 cores, and Genoa X adds over 1 gigabyte or has over 1 gigabyte of level 3 cache on board. That's enough, by the way, that if you're running like Windows 7 in 32-bit mode, you actually have enough level 3 cache, so that's enough RAM to kind of run like a desktop OS from a couple years ago. So that's kind of, or at least the minimum recs for that. It's crazy, right? And as cool as 96 cores is, you now have things like this, which is the AMD EPYC Bergamo. Now, these go up to 128 cores, 256 threads per socket. You can have 2 of them in a server for 256 cores. And so what that practically means is that people can now do projects even today where you can get 4-to-1 or higher server consolidation ratios, even going from like those $10,000 super high-end parts from just like 8 to 10 quarters ago. Like, that's insane. And if you think that's crazy, just wait until we get to mid-2024. Intel's coming out with their new Sierra Forest AP processor, and that will carry a total of up to 288 cores. So if you think about that for a moment, in the span of 12 quarters, we'll have gone from several years of having 28 cores be the absolute maximum to Intel will have 10 times as many cores in a server socket than it did. I mean, that is just absolutely wild. Now, a big part of what's making this possible is the realization from a number of chip companies, really led by the cloud providers, that says, hey, you don't necessarily need the highest performance, all acceleration in a core that you're just kind of using for like a web server or something like that. Instead, you pretty much just need to be able to run a web server. And so what has happened is we've started to see a split in the server CPU cores where you have like the highest performance cores on one end, and then you have more density optimized cores that don't necessarily have all the accelerators. Because, well, frankly, so many people these days are getting things like GPUs for AI acceleration. You don't need to go build that into each CPU core because it can be more efficiently done with an accelerator. And oh, by the way, if you think 288 cores is a lot, just wait until what's next. But one of the biggest trends and most important trends in the data center is what people are doing with these more power efficient cores. They're using those cores and they're saying, hey, if I get the faster processors, well then in my limited data center space and power budget, I can then take the amount that I'm using for all my normal virtualization and just kind of like all my enterprise apps and all that kind of stuff, and I can shrink the footprint of that by like 75% or more. And by doing that project, it opens up floor space for things like AI servers and power for AI servers and all of that kind of stuff that are really driving a lot of the spend in the data center these days. And alongside the march of core counts, the other thing that we're seeing is networking is going absolutely crazy. It used to be that 10 gig was pretty good, especially when we started STH. It was like 10 and 40 gig Ethernet. Those were maybe 40 gig was something that you use like switch to switch as an uplink, but 10 gig was to a server. But nowadays, oh my gosh, like 25 gig is starting to be kind of like that kind of base level low end networking. And what we're seeing is a march to faster things like having 100 gigabits per second to each server. When we start talking about AI servers, folks are already putting 400 gig networking, whether that's InfiniBand or Ethernet, and they're also looking at things like 800 gigabit Ethernet, and that's gonna be a lot more common when we get into 2024. We're already starting to see switches, and we started to see switches on the STH main site about that. And then probably late 2025, 2026, somewhere in there, we're gonna start seeing 1.6 terabit per second switches, which is crazy. Now, unfortunately, I don't have an 800 gigabit switch on hand or switch chip on hand, but what I do have is a Broadcom Tomahawk 4, which is a 64 port, 400 gigabit Ethernet switch chip. And if you just wanna see one, they do look a lot like modern CPUs. They're just giant with tons of IO on the back. But the important thing to remember is that if you're gonna do something like take a single server and have 10 times or more as many cores as you had just 2 or 3 years ago, well, all of a sudden, it doesn't necessarily sound crazy to go and have 10 times as much networking going from 40 gigs to 400 gigs. And on the AI side, distributing all of that communication between all the different nodes that are doing stuff, pulling in data and training data really quickly, all that kind of stuff, it also doesn't sound that crazy to have multiple 400 gig networking endpoints or NICs in a single server. Now, the final topic I want to talk about is liquid cooling. We've been doing a ton of liquid cooling content, whether that's going to the Cool IT labs up in Canada. I recently visited Supermicro and we did an entire thing kind of walking you through Supermicro's liquid cooling solution. We have one from Quanta that'll be live maybe before you see though, maybe a little after that on the STH YouTube channel. And we have a ton of content coming out on liquid cooling. The reason for that is it's such a big topic in the industry. By using liquid cooling instead of using fans to just kind of push air through servers, you can do a couple things. Like one, you can generally save somewhere between 10 and maybe 20% on your overall power consumption just from that. And lower power consumption means lower cost around the same footprint, or it means that you can fit more servers because that's a big challenge right now, which is power density. The other thing though, looking ahead to 2024, is that a lot of the really high-end chips are going to require liquid cooling. So something that you're gonna see starting really like next year is that as folks transition to this era of like 1 kilowatt and higher AI accelerators, you're gonna have to go to liquid cooling to be able to handle that kind of heat out of like high-end servers. The other thing is that the CPUs that we have today, they're also going to increase their TDP. So let me take an example and just kind of going back to the AMD EPYC example. A modern AMD EPYC high-end CPU is probably somewhere in the 350 to 400 watts, depending on the model that you get. But that is going to go up to 500 watts before too long. And in fact, I fully expect that before the end of 2023, we're going to see the MI300, which will have higher TDPs than 500 watts most likely. So even though the number doesn't seem that much bigger going from like say 350 or 400 watts to 500 watts, one of the challenges is that in all of the really dense like blade servers and all these other kind of like dense units that you have of compute, you're going to need to have liquid cooling just to be able to run the highest end modern CPUs. So your high-end AI servers are going to need it, your just kind of high-end CPUs are going to need it, but frankly, a lot of just kind of like lower end, like if you have 32 cores in a server, you're not going to need to go to liquid cooling. However, let me point this out. If you have seen my previous talks and you just said, oh, he's talking about liquid cooling, who cares? Well, if you want to go get in on liquid cooling for the next generation of 2024 hardware, you're probably already too late. You're probably missing the 2024 generation, and maybe you'll be able to use high-end hardware in maybe 2025, 2026 or something like that, because all the organizations that are going out and really want to deploy high-end compute for next year, they're already doing liquid cooling in their data center in some form or fashion. If you run infrastructure at your company or you have a client that runs infrastructure, you want to be talking about liquid cooling now, because for the highest end compute, you just are gonna need it. So hey, I hope you like this look at all the really cool stuff for next year, like, you know, the AI servers, the CPUs that are going crazy in their core counts, networking, some of the liquid cooling stuff. We covered a lot in this video, and if you want to learn more, well, there's a couple of easy ways to go do that. First, you can go check out the STH main site. We have reviews all the time of this, as well as some fun, really kind of edge boxes and stuff like that. But we also have the STH YouTube channel, which we're trying to get to 400,000 subscribers by the end of 2023. So if you haven't subscribed already, why not? We have some really cool stuff on there that I think you guys will like as well. And that is the end of my Netrio Nugget 2023 presentation. So with that, thanks for watching and have an awesome day.